This is to investigate task number 7, which asks us to understand why we can define a plane using the notation XYZ such that Z is 2. So I'm back in the XYZ plane as seen in GeoGebra. I'm going to go ahead and type in just the XY0 plane. And what's illuminated at this time is actually the old-fashioned traditional Cartesian XY plane. And what we're going to show is that no matter what my entry is in the XY field, if my Z stays 2, I'll get this exact image, which will then define a plane. Realize that when you are defining a plane, you only need 3 non-collinear points to go ahead and do so. So what I have now is showing the XY2 plane. And then I'm also going to then try just showing 1, 2, 2. And this is XY2. That's the plane. And any point on this plane, as long as my Z value is 2, is going to eventually maintain that plane. And again, the definition of a plane is that we need to have 3 non-collinear points appear on that plane, and a plane is 2-dimensional, which is why it is showing up just like that Cartesian plane did. Additionally, I'm going to go back to the Cartesian plane. So here's the Cartesian plane illuminated, and anytime that I'm putting in that Z value of 2, I'm really just taking my plane and I'm translating it up 2. So that's why the properties of it are able to be maintained. So again, if you're noticing the screen switching, I am just going back and forth between Cartesian, which is this, entering in the Z of 2, and it is the same exact thing, just translated to the north 2 values.